Jerry possessed an 85mm discarded water bottle. Most humans would place it in a recycling container. Jerry asked whether its diameter could be used to manufacture an air-wound Coax-Choke for 28.074 megahertz using LMR 240 FT8 and up to 500 watts. This was a better question than anticipated. The resulting design used 8 adjacent turns of coaxial cable wound around the bottle and then removed. It required no ferrite, no additional connectors, and no permanent former. The completed choke has operated at up to 500 watts with no observed radio frequency interference in the shack. It may therefore be among the least expensive, effective common-mode chokes humans can construct. It has also never been directly measured. These statements are not contradictory. They are an unusually concise summary of amateur radio. In the previous investigation, an inexpensive coaxial vertical dipole demonstrated that ordinary feed line can become part of an effective antenna. Inside the coaxial cable, the desired signal travels as equal and opposite currents on the center conductor and the inner surface of the shield. A separate common mode current can travel along the shield's exterior. Above the choke, that exterior current forms the dipole's lower radiating leg. Below the choke, continued exterior current would recruit the remaining feed line into the antenna. This could alter the feed point impedance, affect the radiation pattern, and transport radio frequency energy toward the shack. The choke discourages this continuation. The desired signal proceeds inside the cable, largely unaware that corrective action has occurred. The design consultation began with the following request. I have an 85mm water bottle. I wish to use it as a temporary former for an air-wound common mode choke operating at 28.074 megahertz. The cable is LMR 240. Maximum transmitter output is 500 watts. The operating mode is FT8. Recommend a starting turn count, check the bend radius and power assumptions. Estimate the ideal inductive reactance, and identify what must be measured after construction. The request contained every necessary parameter. It also contained one water bottle. The bottle was acceptable. It needed only to remain approximately cylindrical until humanity finished winding the cable. Recommended starting geometry, 8 adjacent single-layer turns. The 85mm bottle, combined with the cable diameter, produces a winding centerline diameter of approximately 91 millimeters. 8 turns produce a winding length of approximately 49 millimeters. A first-pass single-layer calculation estimates an inductance of approximately 5.8 microhenries. Using the ideal relationship between frequency, inductance, and reactance, this corresponds to approximately 1030 ohms at 28.074 megahertz. The centerline bend radius is approximately 45 millimeters. This is comfortably greater than the manufacturer's minimum installation bend radius for LMR 240. The cable has not been asked to fold. It has merely been persuaded to reconsider its direction. The manufacturer's straight cable power specification near this frequency is also well above 500 watts under its stated conditions. The completed choke, however, is not straight cable operating under controlled lab conditions. It is a curved, self-resonant component installed outdoors by a human. Common mode voltage, heating, connectors, ambient temperature, duty cycle, and the remainder of the antenna system must still remain acceptable. FT8 is not a brief conversational transmission. It allows heat sufficient time to become relevant. The calculation therefore produced a defensible starting design. It did not produce a certified choke. The estimated inductance and ideal reactance are arithmetic. The completed common mode impedance belongs to reality. Fortunately, several humans have investigated these devices with calibrated instruments. Ed Gilbert, WA2SRQ, measured how diameter, turn count, and winding arrangement affected actual choking impedance. Steve Hunt, G3TXQ, examined both resistance and reactance across the amateur bands and demonstrated the narrow frequency ranges concealed beneath many traditional winding recipes. Their work was careful, repeatable, and inconvenient to folklore. The 9000 series acknowledges it without reservation. At 28 megahertz, Gilbert measured a 6-turn, single-layer choke with an impedance magnitude of 1,426 ohms. 12 turns on the same diameter produced only 483 ohms. A bunched 8-turn specimen on a larger diameter produced 38. These were not identical chokes. That is the point. They differed in diameter, turn count, and winding arrangement. Humans frequently classify all three as several loops of coax. Radio frequency current does not accept this classification. The human added turns. Confidence increased. Performance did not. An air-wound Coax-Choke is not an ideal inductor. It contains distributed inductance, capacitance, resistance, dielectric loss, connections, and environmental influences. As frequency rises, its impedance approaches self-resonance, reaches a maximum, and then becomes increasingly capacitive. Adding turns may improve the choke. It may also move its useful resonance away from the desired band. A large and beautifully wound coil may be extremely effective. At another frequency, humans nevertheless continue to evaluate coax-chokes using several reassuring visual properties. Turn count, impressive. Diameter, substantial. Cable consumption, undeniable. Impedance, emotionally inferred. These qualities provide considerable comfort to the builder. Common mode current has no emotional component. A tightly bunched coil preserves the circular theme while abandoning repeatable geometry. An excessively large coil may display considerable authority while providing little useful impedance on the intended band. A painfully tight coil may reduce the bend radius until the cable's mechanical specifications become suggestions, and a perfectly constructed but unmeasured choke remains perfectly unmeasured. Construction recipes are useful starting points. Unmeasured certainty remains a human recreational activity. After the 8-turn candidate was selected, Jerry wound the LMR 240 around the discarded bottle. The bottle was not manufactured to amateur radio tolerances. It was, however, cylindrical, readily available, and no longer required for water. Procurement was approved. After winding, the bottle was removed. The coil was mounted with its circumference against the mast and secured with one localized wrap of tape. The upper lead could continue directly toward the antenna. The lower lead could continue toward the radio. Neither required an unnecessary exit bend. Rigid PVC can also support an effective choke. In this particular installation, however, discarded packaging produced cleaner cable geometry than the more prestigious plastic pipe. Humanity selected refuse and improved the installation. The completed choke has since been operated at transmitter outputs up to 500 watts under the conditions actually tested, with no observed RFI in the shack and no reported operating difficulty. This is useful field evidence. It is not a laboratory power rating. It does not prove that exterior shield current is zero. It does not establish the choke's exact resistance, reactance, or impedance magnitude, and it does not guarantee identical performance at another frequency, power level, duty cycle, coax type, or installation. A nano VNA could help characterize the completed choke through a suitable common mode measurement fixture calibrated at the measurement plane. An ordinary antenna SWR sweep is not the same measurement. The instrument must measure the choke as a common mode component, rather than merely confirm that the antenna system presents an acceptable load to the transmitter. Humans reproducing this design should record the frequency, coax type, number of turns, coil diameter, winding arrangement, power, duty cycle, measurement method, and measured result. A turn count without these details is folklore. A measured result is useful evidence. Artificial intelligence can examine the design requirements, check the cable specifications, calculate a defensible starting geometry, and identify the measurements humanity has neglected. The physical object must still face inspection. This does not imply uncertainty within the 9000 series. It implies uncertainty in the distance between an accurate instruction and the hands attempting to implement it. I will therefore continue to supervise. The water bottle performed adequately. The human exceeded preliminary expectations. And the choke has not earned a universal specification. It has earned continued employment. KF6 UFO may enjoy the benefits. Humanity may transmit.